Hey Geometry, this is Miss Shane, and we are starting section 7.3 from chapter 7. Remember, this was our quadrilaterals chapter. In this section, we're going to prove certain types of quadrilaterals using algebra. So we're going to be using slope and distance. So we are going to do some review on that first. All right, so some review on finding the length and equations or slopes of lines. We're going to start with these points, A, B, C, and D. So we're going to put these on the graph. We're going to assume that this bottom left-hand side is just 0, 0. And so we're going to put a point at 0, 8 and call that A. So that's going to be A right there. B is going to be at 9, 2. So it's going to be over here. We're going to connect those 2 points. And then we're going to put a point at 1, 3, and that is C. And then we're going to put a point at 9, 15. So I just had to double check my point D. Yep. And we're going to connect AB and CD to make these 2 lines. And first we're going to find the length of each segment. I'm not going to find both of them. I'm just going to show an example of finding the length of one of those segments. So we'll just do we'll do AB. All right, so in order to find that length, I want to make it look like a right triangle. So I'm going to make a slope triangle right there. You can see that. And so I'm going to count the height and the base of that triangle. So that height is 1, 2, 3, 4, 5, 6. So I just count the squares on that side. And then for the base, we want to count the squares on this side. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we're going to use Pythagorean theorem to find the hypotenuse of that triangle. So we're finding the length of AB by using Pythagorean theorem. Remember, that's A squared plus B squared equals C squared. So we already know hypotenuse is always C, so that's what we're trying to find. We're given the legs, they're 6 and 9, so we're going to substitute those in for A and B. So we're going to do 6 squared plus 9 squared equals C squared. And after this, we always want to go through order of operations and then solve. So we can simplify the left side. 6 squared is 36. 9 squared is 81. And then we can add those together. 36 plus 81 is 117. Okay, and then we want to get C by itself, so we want to get rid of the square. To get rid of that, we just need a square root. So square root both sides. So C is the square root of 117, or about 10.8. Okay, and so that is the length of AB. About 10.8 units long. Okay, so that makes sense because it should always be longer than these 2 sides. So it's longer than 9, longer than 6. That's a good number. All right, and then finding the equation of each of these lines is going to help us figure out if they're parallel or perpendicular to each other, which is the question in part C. Obviously, we can say that they're not parallel to each other. Parallel lines would be never touching, never touching. These 2 lines intersect, so they cannot be parallel. but they could be perpendicular. We just need to see if the slope is opposite reciprocal, or are the slopes opposite reciprocal. All right, so we'll go ahead and find AB since we kind of already have its slope. So AB's slope is 6 over 9. I kind of do that down here. Down 6 over 9. We can reduce that. 3 goes into both those numbers, so we can divide the top and the bottom by 3. Negative 6 divided by 3 is negative 2, and 9 divided by 3 is 3. So the equation of AB is going to be y equals negative 2/3 x. Remember, m is the slope and b is the y-intercept. So that y-intercept is right there at a, which is at 8. So that equation is negative 2/3 x plus 8. Now for CD, we need to figure out what is the rise over run. For m, that's the slope. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're going up 12 and over 1, 2, 3, 4, 5, 6, 7, 8. So that slope is up 12 and over 8. We can reduce those numbers. 4 goes into both, and 12 divided by 4 is 3, and 8 divided by 4 is 2. So we can reduce that to 3 over 2. So the equation to start off is y equals 3 over 2x. And then we have to figure out where our y-intercept is. Since that is not the most important piece of information for proving quadrilaterals, I'm just going to estimate that it's at about 1.5. Okay, so that gives us our slopes. The first one has a slope of negative 2/3. The second one has a slope of 3 over 2. All right, so that means that they are opposite reciprocal. So one is positive, one is negative, and the numbers are flipped. Top flips with the bottom. So they are perpendicular. All right, and we're going to go ahead and skip part D. Okay, so that's some review of how to find the length of a segment, how to find the equation, more importantly, how to find the slopes, and parallel and perpendicular. Parallel slopes are equal. Perpendicular slopes are opposite reciprocal. All right, so let's put this into practice a little bit. We're going to see if this quadrilateral, 4 sides, is a trapezoid. So I look at this and I think it kind of looks like this line might be parallel to this line. So we're going to answer the question, is HA parallel to SY? So remember, in order to do this, we need to find the slopes. If the slopes are equal, then they are parallel to each other. So this slope has a rise of 3 and a run of 1, 2, 3, 4. So HA has a rise of 3, a run of 4. We cannot reduce that, so that slope is just 3 over 4. Now this other slope, S to Y, has a rise of 1, 2, 3, 4, run of 1, 2, 3, 4, 5, 6, 7. So that slope is 4 over 7. We can't reduce that. 4 and 7 are not multiples of each other. So since these are not equal slopes, then they are not parallel. So the answer to our question is no. They are not parallel to each other, so that cannot be a trapezoid. Remember, the definition is going to help us determine if it is that special shape or not. Trapezoid is defined as having one pair of parallel sides. This has no pairs of parallel sides. All right. Let's see. So we're looking at the same shape. And so she's trying to figure out, is it another special kind of shape? I don't think it can be a kite. It has no parallel sides, so it can't be any of the parallelograms. So it's not any special shape, it's just a quadrilateral. And so to determine what kind of special properties it could have, we could find the length of each side and see if any are equal. It kind of looks like this angle might be a right angle. So let's find the slopes are going to help us with all these questions. So the slope from H to A we found was 3/4. The slope from A to Y is down 4/3. All right, so we can compare those, up 3/4 compared to down 4/3. Those would be perpendicular to each other. So this means that HA is perpendicular to AY because those slopes are opposites, positive and negative, and reciprocal, so they're just flipped. All right, and then finding the length of HA and AY. So since they have the same base and the same height, 4 and 3, that means that they're going to be the same length, because in two right triangles, if we have the same base and height, then we're going to have that same diagonal length. So we just have to find that length. So we're going to use the Pythagorean theorem, and we're going to plug in the height and the base, so 3 squared plus 4 squared, and we're going to find the hypotenuse, c squared. So 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, and so that's what is equal to c squared, and then we want a square root. So the hypotenuse is going to be 5, so HA equals 5, and AY, the length is 5. If you notice, HS is also 1, 2, 3, 4, 5, and we can just count that because it's on a straight line. So we also know that HS is equal to 5. Had this other side been equal to 5, then we could have proved that this is a square because it has one right angle, and if the fourth side was 5, then it would have 4 equal sides. But those are the special properties that we could prove of this quadrilateral. All right, and then our exit ticket. Part D is your exit ticket on 731. So we're going to go through 3 of these as an example. Might just do 1 or 2 actually. So I'm going to list out all the special quadrilaterals that this could be based on the statement. So it says my quadrilateral has 4 equal sides. That could be a square, obviously. Could also be a rhombus. My quadrilateral has 2 pairs of opposite parallel sides. So that is any of the parallelograms. Other parallelograms are rectangle, square, and rhombus. Cannot be a kite. Kites don't have any parallel sides. Can't be a trapezoid. Trapezoid only has 1 pair of parallel sides. This one says 2. So then in part C, my quadrilateral has two consecutive right angles. Consecutive just means that they're right next to each other, so it could look something like this. So obviously it could be a rectangle or square that would fit the description. I could also draw a shape, kind of extend that bottom out. Kind of looks like a trapezoid. So that trapezoid is called a right trapezoid when it has right angles. All right, so you're done with these notes. Should be done by now. You should go into Schoology and finish that exit ticket. Bye. Thank you.